if we look at letter B, we've got 2 times the square root of 45b to the 10th. So the first thing I'm going to do is work with my 45. The biggest perfect square that goes into 45 is 9. So that's 9, square root of 9 times the square root of 5. The square root of 9 is 3. And remember to take that times what's already on the outside of your radical. So 3 times 2 is going to give you 6. We're going to leave a little bit of space for our variable, and then we have square root 5. Once again, the rule for an even exponent is divided by 2. And 10 divided by 2 is 5, so the square root of b to the 10th is b to the 5th. So your answer for letter B is 6b to the 5th times the square root of 5. And let's try one more. Letter C, we have to simplify the square root of 20a to the 14th. So I'm going to break down 20. The biggest perfect square that will go into it is 4. So we've got the square root of 4 times the square root of 5. The square root of 4 is 2, and there's nothing to multiply it by on the outside, so just the 2 comes out. We're going to leave a little bit of space, and then our square root of 5. The square root of a to the 14th would be to divide it by 2, and we end up with a to the 7th. So your answer for letter C would be 2a to the 7th times the square root of 5. Okay, in example 3, we're going to do pretty much the same thing as we did in example 2, except we're going to have odd exponents. And once again tomorrow we'll talk about the reasoning why this works. But when you have an odd exponent, you're going to do things differently than with an even, because we can't just cut 9 in half. We're going to end up with a decimal, and we don't want decimals as part of our answer. So to start this out, I'm going to work with the square root of 27. The square root of 27 would break down into the square root of 9 times the square root of 3, because 9 is the biggest perfect square that will go into it. The square root of 9 is 3. We're going to leave a little bit of space again, and then bring down our square root 3. Now the shortcut when you're working with an odd exponent is to borrow 1. So instead of a to the 9th, I'm going to make it a to the 8th. I'm going to make it an even exponent. But the one that you borrow, so I borrowed an a, and I can't just forget about that, so I have to bring it down and put it under the radical sign. So this would be the one that I borrowed. Now I can take the square root of a to the 8th now because it's an even exponent, and I would cut it in half, and 8 divided by 2 is 4, so a to the 4th would come on the outside. So your answer for this one would be 3a to the 4th times the square root of 3a. If we try another one with an odd exponent, we'll worry about the exponent in a minute. Let's break down our 60. Okay, if we look for the largest perfect square that goes into 60, it would be 4. So this would be the square root of 4 times the square root of 15. The square root of 4 is 2, so that comes on the outside. Our 15 stays under the radical. And now we have to deal with our exponent, and our exponent is an odd exponent. So we're going to borrow 1 and make it a 10. But the one that we borrow has to go under the radical sign. So the t that we borrowed comes after the 15. Now we can take the square root of t to the 10th by cutting it in half or dividing by 2. And 10 divided by 2 is 5. So t to the 5th power comes on the outside. So our answer would be 2t to the 5th times the square root of 15t.